I don't know who wants to go first, or Al, how did your demolition go today?
I should log in on my phone and go out in the garage and show you. So with Matt's help and guidance, we're down to the frame and trying to build back up to mount the motor. I'll tell you what, I'm going to go grab my phone and somebody else can comment, and then I'll try to actually show you what it looks like. It'll, as they say, a picture's worth 1,000 words. I'll be right back.
Okay. Jeff, do you make any progress on your robot?
Well, I've been playing with a microcontroller trying to get the peripherals initialized, and I can read 3 quadrature decode channels. I can run several PWM channels, and I've been playing with the ADC. It turns out that the way I thought it should work will only read a single channel. So I just looking at some videos, and I found one that says if you set it up with DMA and you tell it how many channels you have, it just automatically scans and keeps an array updated for you. So I'll probably try that.
What's DMA?
What's DMA? It's direct memory access. Okay. So it's an extra controller inside that you point at some memory, and you say you can either do memory to memory transfers, or you can point to a peripheral and point to memory, and just automatically in the background transfers data for you when it's time to do that. So it's just something extra they've got built in to help you out.
That's on the STM32?
Yes. I started off trying to read 2 pins, and it turns out it reads twice, but it keeps reading the same pin. So there's some trick about when you read it, you have to tell it to increment to the next channel or something. And as I say, I just found this demo on how to do it with the DMA channel, and that looks like it'll take care of it for me, at least to get me started.
Is that like an Arduino compatible chip, or is that totally different?
Well, you can get an Arduino IDE that'll talk to it. So, you know, as far as when you say Arduino, they can run various chips on that now, and if you're going to use an STM micro with Arduino, then somebody's written libraries so all the functions work with it. So it's technically not, you know, the chip itself is not compatible across the different devices, but in general, yeah, you can just run Arduino code on it. So that would be an option, but some of the Arduino functions, I'm not quite sure what they're doing, and I don't want to go down the path of getting so far and thinking, oh, I have no idea what it's doing now. So I'm going to try doing it with just straight C code to start with.
Brave man.
Well, you have to start somewhere.
Al, are you ready for the demo, the live demo feed?
Yeah, it's like Facebook Live or something. Let me turn the, let's see, how do I do the camera thing? Oh, here we go. So this used to be a Cub Cadet tractor, and we've taken off the all the yellow bits. I've kept the shaft on, and the reason I've kept the shaft on is because I was trying to figure out the right way to mount this motor. So I don't know if I'm holding this and you can see that very well. It's a little bit, give me some feedback, Matt. Can you see that very well? Okay, yes. I'll take that as a no.
That's a yes. No, we can see it.
So you can see the angle that shaft is, and I'm hoping to mount the motor equivalent with that angle. I 3D printed this spacer purely to give me 100 millimeters up off of this gear in order to do the connection to the shaft. And so I've gone at it 2 or 3 different ways, all frustratingly slow. But so my next maneuver is, come on, go in there, is to 2 mounts, one through that hole down to those bolts, and basically hold it effectively right there. If you can get a sense of that, if the camera angle is any good. Another interesting discovery is you can see that I've taken the gear out of that motor. This is what that looks like. It's the nylon gear, actually, and a little bit of ingenuity, we could probably find somebody to 3D print a gear like that and put our own shaft in that motor, but that's at the moment beyond my skills. It's fun to think about. So that's where we're at. Demo done. 2 or 3 different mounting positions thought through and discarded, and now on to the 3rd or 4th approach to mounting that daggone motor.
Yeah. Oh, you're welcome. Thanks for coming in.
Any brilliant? Oh, I've got a friend who will make a bracket for you. That's already been done. Anyone?
Do you have a design? I mean, did you have a design in mind?
I've tried to work through 2 or 3 different things, Sam, and none. I was not happy with them.
Okay.
So I'm on to another design.
Okay.
It's what did Thomas Edison say? If you you rule out everything that doesn't work, then that which is left is the solution. So, I was trying to use a quip from Michigan to honor the Michiganders.
Just try 999 different things that don't work.
If all else fails, you can use a hose clamp.
There you go. Might come to that.
No, I like your mounting bracket. That's a big motor to shove in there, but that's pretty powerful.
Yeah, that is a heavy beast. I've not weighed it, but that's got some weight to it.
So do you want to have the motor and then you're still able to steer it manually? Or what's the idea?
But for me, I was not going to try to have a dual steering thing. I was all in.
Okay, so the only option is so you need to just connect the motor to the shaft and not have a steering wheel. Yeah. Okay.
Right.
Yeah.
I remembered the story, or I don't know if it's an actual story, or I think the ship's captain name was Cortez, and the story is, he landed on the shore and he burned the ship so men would have to fight for survival. I'm all in.
Yeah.
Automation or bust.
That's exactly right. Automation or a scrap heap.
Yeah.
Looks good, Al. starting to look like a robot.
Looking like something. It's good fun.
Owen, you want to give us an update? Let everybody know the news.
Oh, yeah. So I'm going to be starting to work with Kyler soon. I've, I've just accepted a job offer from Sabanto, so I'm really excited about that.
Congratulations.
It's going to be fun. Yeah.
Sam, you ready for a demo? Sam, looks like you're frozen there. Evening, Colin. Sam's been working on, there he goes, he just logged out. But, he's been working on the simulator. We're using Owl's Farm as the simulation field. I don't know where his connection went there. Colin, what's happening with you?
Nothing. Fine. How are you, Max?
Good. Al's getting a little ahead of you. He tore apart his lawn tractor today, so he's going to start mounting actuators and motors and sensors.
Okay.
Don't let him fool you, Colin. That sounds easier than it actually is.
Welcome back, Sam. Do you want to try the demo or update on what you've been working on?
Yep, let's do it. Let me open up the screen share. So a little bit of background, right, on the lawn tractor side. What Matt gave me, kind of a, the question about how to use the, the PGM PNG file where we were trying to do the map. And then I think we got the coordinates for the Alt's farm, and then that's what we were trying to draw, and then use that as a map. So we just tried that, and the things in the maps is coming up, right? We have actually lots of moving parts for the lawn tractor simulation. The one is we're using the stage ROS. The other one is our frames, like what we use, the GPS and the camera frame and the base link and the base footprint. Also, we have the map frame, UTM, and the ODOM, obviously. So it's all there when we start the demo. They're like not perfect, and still probably needs a little bit of fine tuning, but I think good part of all of this is just all the moving parts. It started to look like that it will work in the simulation, and it was yesterday that I was able to visualize the base, the move base with the tractor that was actually moving in our ways from point A to point B. So let's try and take a look at that. Let me share my screen. Okay, so this is very rough approximation at this point. As you can see that we got the robot model. I'm up my fixed frames map at this point. And then I also got the footprint, base link camera, and GPS. They're like all situated right at the base footprint at this point. And then my camera and my GPS link a little bit off, the center. But at least we can see the visualization that, of the tractors is almost here. So let me bring in the map, and then we can start listening to the map so that once the map server starts, we can take a look at that how it is positioned at this point. So I'm just going to do bring in the map. And we'll just list, as soon as you start listening to the map topic, it will actually pull in the map. Let me see. It should render. I'm just checking that if the map's running in the background.
You may have to click somewhere else for it to accept the fact that you selected map there.
Alrighty, so the map loaded, and then as we can see now, so this is the PNG file that I use, and I'm just going to go ortho so that we can actually take a look at where it is right now exactly. So this is the rough coordinates, of the farm at this point. And then what I did is, in order to create the PNG file, obviously, I took all of these coordinates and put it into the CAD, the file. And then once I get the coordinate, I just brought it into the GIMP. And then I actually bordered it around. So it means that my map server would recognize this. For example, at this point, you have all this, the white space over here, which is basically being read by map, which is the open area, and then all the, all the black outside borders, which is basically read by the map that, you cannot go there. And then we also localize like the tractor right here. So that it's just, and then right now my map is in the world 00 coordinate. So it means that I have situated the tractor right now on the left side of, the map, which is like kind of minus 30, the position at this point. So my world starts from the center, and then my map situated at minus 30 coordinate. Now we are using the ENU frame, meaning, you got the all the east is your, the X is your east, your Y is your north, and then your Z is your usual Z up. Let's bring in the other, like for example, let's bring in the pose, and then let's listen to the topic where we just have the current goal, and then also we can bring in the odometry, sorry, and then let's listen to it. So now the odometry at this point is just being published by Stage ROS, which is one of the other simulation software that we're using for this. So this is getting the data from the odom. And and once this is over here, like everything's, situated, I just wanted to show you also all the nodes and then all the other details, that we have. And then we can come back over here and then just move the tractor and just to see it moving. Let me see if we have any other, if we can go by the topic, if we have any other thing that we can bring in. No, I think that should be good. Okay, so let me fire the another terminal and let's take a look at all the data that we have. Okay, so I'm just going to stop share over here, and then we're just going to share a new share. which is BMT. All right, so you guys can see my terminal now.
Yep.
Is the Linux terminal. So I'm just gonna pull in all the nodes. So right now with that simulation file, we have the map servers mapped to ODOM. That's just one node, the UTM, the move base. This is the custom node where it just trying to convert the ODOM data to the its lat long and altitude. And you got you can see the state ROS. This is also running. And you got also the tractor visualization and the vehicle state publics running in the background. So let me, zoom out that. And then also we can do all the ROS topics just to see that how many, the topics are running. So you got.
Are you showing anything, Sam?
Sorry.
Sam, are you showing anything on the screen?
Yes, I should have my Linux terminal on this screen share. Can you guys see it or no?
I can see Ross topic list that you just entered.
Okay.
Yeah, I can see it too. Yeah.
Mine is blank.
Oh, it should come up.
Okay.
Let me know if it gets refreshed or if it doesn't. So here is like if we see all the list after all the ROS topics over here. As you can see, that some of the interesting, the list is over here. We got one of the topics that actually is just publishing the GPS and the UTM. There were like also the initial. There is a map and map metadata. Both the topics are also running, and there's an AUTOM which is also being published, and we do have a TF running. So these are the important topics that we just wanted to. And let's take a look at one of the topics where we just see the map metadata. So if I say. Okay, let me see. So map metadata is so it will give me like the map that we're using. So it will say that the map that I'm using has got the resolution of 0.1. And this means that I'm using like about 0.1 meter per pixel. So it's like my pixel resolution is like about 10 centimeter. 10 centimeter per pixel. The width that it's using is about 1411 pixel, and then the 1168 it's the height of the total area of the image. The map that I'm using and my position in terms of the origin is minus 30. Now remember, this is in terms of the world, the coordinate frame, which is right into the center. Now that word data, it's coming from, I think, from the stage. So that's why we just put that, and then you can see the localization, just like at the beginning, the tractor is right at the minus 30 meter west and minus 30 meter south kind of deal. So it's like right into the southwest corner. With the center, the word coordinate, it's just right at the center. Okay, so that's this. Also, there are some other, like, let's say for example, there are some other, the commands that you can see, like now fake GPS. We can just listen to the fake GPS at this point, which is just actually publishing. And then so we just echo it, and then just wanted to listen it to, sorry about the just one time. So can take a look at this. It would just the echo the result one time what the topic is actually spitting out. So at this point, it will say it's getting into the header frame IDs over here is map, and then it has the static the let and long. And then it has the altitude, and then the covariance is just like everything's 0 at this point. So this is what we're getting it from the fake GPS. We also got the fake UTM, as we have seen over here. Sorry, seen over here, and then that is nothing but the conversion of the GPS data into the UTM coordinates. So we can also actually check that if it's publishing anything, and it's just basically converting my the lat long that we have it over here into the plain UTM frame. So this is like 3340 and then 779. Those are all in meters, and I'm not sure the zone's not here right now because we're not probably publishing it with the fake UTM, but then you can see the lat long, in the UTM coordinates over here. This is if you just can convert back and forth from UTM to the lat long, this is called the WGS 84 convention, which is like the regular GPS convention, and this is called the UTM convention, mostly used by military purposes and some of the aviation purposes, I guess. But we have, and this was talking with Matt. This was not directly used. That Matt has not seen it. I'm just trying to figure out that if it has any usage in RS, but. This is like, the projection is pretty simple. It is the 2D grid and it's in meters. So, and then also it's like easting and northing. So it means that it's also in line with the coordinates that we use in ROS, which is our ENU frame. So it may have some usage, but we haven't found anything regarding to our, launch tractor at this point, or even in overall ROS, but we'll update you if we find some use cases which is useful. What else? Let me see. The ODOM, yeah. So we can also listen to the ODOM, which is the important frame. I mean, it's just coming from the stage ROS, which we're using, and then the interesting thing about the ODOM is, so this is what it has: the header frame, which is ODOM, and then child frame, which is not publishing right at this point. So this is one of the areas where we need to look into that. While child frame is not coming, but it is giving us the pose and the twist data. The important thing about the ODOM is you have to remember that the header frame data is in the map frame, and most of the time the child frame data is into the base link in most cases, and then the twist data would be in the base. The twist data would be in the base link data, and then the position data, the pose data would be in your the header frame data. That's just important distinction to probably understand. The another really nice the command to learn, actually, and then I like it a lot, which is like if you go ROS topic and then you say type, and then let's say, for example, for ODOM, right, you wanted to know that what's really the message type and the details, what this has. And then you just pipe it with the ROS message, and then just say show. And it will give you some important information that you wanted to see directly. So, and then if you, it's just a little bit of, if you know how the pipe works, it's just basically pretty simple to take a look at any message type that you have just being published, and then just get the detail. Also, I find one of the interesting, the command maybe, let's see if it works. If I put the -R, actually it just gives me a little bit of the verbiage on like how the ODOM is just being used. And as I said, this represents the estimate of the position of the velocity position and velocity in the free space. The pose in this message should be specified in the current frame given by the header frame ID, which we just talked about, and which is very important distinction to understand, because your geometry of data is just mostly coming from over here. So be it if you use any simulation or any other packages, you just want to make sure that you're just actually using it. Your source is actually it's coming from the one package. You know, if you're using multiple packages. And your twist data is just going to be in your child frame ID, which is like in most cases just a base link, because that's where you just wanted to see your robot move, and then your base link basically represent a rigid link that's attached to the body. So that's where you want to see the twist data. Your header is header, the string, your child frame ID, you just specify like this. You've got the pose, that pose with the covariance, and you got the twist and twist with the covariance. We will go into the detail probably somewhere in future on what's covariance is and why it is important. In some of the terminologies, you will often see that the pose and twist, they're like, it's used with the covariance stamped, but we're not going to go into the detail today. All right, so that's, I guess, a lot of information about what's just being published and what we can see. Oh yeah, one more thing, we just wanted to take a look at the TFs, right? So the TFs is basically just really important. So let me show you, if you wanted to see that right now, if it's just actually like all the TF view and all the other frames, and you just wanted to see the TF echo, if you wanted to see a transform from one frame to the other, and also you wanted to just monitor the one of the frames, that also can be done, because right now just we're not moving, but I think it's just being published. So if I do ROS run, and then I'm just gonna say on TF package, you just wanted to ROS run, it's the view frames runs directly. I'm not sure. Let's try this. Will come. Yep. Okay. So just wanted to run that directly from the TF frame. From the TF package, and then it will just listen to the topic for 5 seconds, and that's actually kind of universal if you just listen it to all the topics. And then now it says that okay, where we got the frames.pdf is generated, so we can actually look at the PDF with the events. This is like I'm using Ubuntu, so it's like my PDF document viewers. It's the events, and then I can directly look at the PDF. Now it comes up. It might come up into the another window. Can you guys see the frame or no?
No.
Okay, let me share that screen where the frame is. Okay, so this is the view frame result. So as you can see over here, where you got your map, and then this is like the whole TF3, and then you got the ATOM, you got the UTM, you got the base footprint over here, you got the base link, you got the camera and the GPS attached. How you read this is basically you got the broadcaster, that is your topic. So you know that what's actually being broadcasted by who. This is your average rate of broadcasting, that like a 10 hertz. The most recent transfers, like how many seconds old, basically ran new, and then your buffer is like about 5 seconds, because you were listening to it like about 5 seconds, and I think that's pretty much constant for most of the transforms. So this is how our links are basically. They're like not perfectly like transforming everything, but the tree itself is actually pretty robust at this point. As you can see that your ATOM and your base footprint, and then the transforms between those is just like being published by the stage ROS. And then there are something there which we're not getting and then I think the map might want to chime in that the ATOM to base footprint and the base link, the transforms, the stage, the ROS, has some issues where it sees the base link and the base footprint. So right now, my ATOM and to my base footprint and the base footprint to base link, it's the transform tree. This is the way I go. If I wanted to have the ATOM to base link transform, I have to go through ATOM to the base footprint to the base link. And I think the stage ROS, what it is doing is it's just considering base link and the base footprint as like identity transform. That's what I read. And that's what it looks like, that where it is. Remember that we saw that the odometry message, and it had the frame ID, and it has that, the odom over there, but there's no, the child frame ID there. We didn't see that it should have been a base link over there, or at least a base footprint. But anyways, so this is all working. This is all you can see that, okay, well, this is just gonna, excuse me, this is gonna work. Now let's.
One question: why do you have a base footprint between ODOM and base link? If you follow the conventions, I think base link is a child of the ODOM frame.
Correct. So most of the time, let's say, for example, your base link is in our acronym, the style vehicle, which is, we have the tractor, and thanks to the map, the center of the rotation for this, the understanding, that now I have it clear. So your base link, you wanted to put it right at the center of the rear axle, so that is your center of rotation, for the acronym vehicle. And you put it over there. So it means that your footprint, it's supposed to be your, the top down, the ortho projection that would actually give you the base footprint. So the transform, in most cases, from base link to the base footprint, it should be simple. It should be X, Y equal, and Z equal whatever the distance, from your center of the rear axle all the way down to the ground. And that's why I think we have to introduce the base footprint over here. And we have seen that in a lot of, the cases that, that's how the base footprint is being also introduced. Also, footprint actually helps you avoid obstacles because that's right at the ground. That's the assumption. So that, the people use the boost, the footprint. But if you think that you don't want to use the footprint and you really wanted to actually just use the base link, and then you wanted to connect all your static transforms from like camera and GPS to the base link, I think you can do that too. Depending on the use case and depending on the requirement, I guess you wanted to use the footprint.
Yeah.
Tommy, are you saying that maybe we could put the base, since ODOM and is ODOM the direct position underneath the vehicle as it's moving?
Yeah, so base link, I would just try to have base link as a child of ODOM, and probably just have it on the ground and then define the footprint. I don't know, as child of base link or something.
Or a child of the ODOM.
So it needed to be the base footprint. That's for the obstacle detection.
Yeah.
Mostly, we have seen that house is being used.
Yeah.
But we've also seen that the base footprint is just dependent of the base link, basically, and with the ODOM. But I think depending on the use case, if you directly, your ODOM's the parent and the base link's the child, should work too. For the most prototype, if that's, the easier, unless you figure out the use case, that there's actually is easier to introduce the base footprint in your TF3.
Okay.
Because transform's easy.
That would fix the stage problem. So right now, the way we have it set up, base link and footprint are equal. So we don't get the height on the base link. So all of it's squashed. But if we move the base link to the ODOM and then put the footprint as right now, Stage is publishing the base footprint as a child of ODOM. But if we attach the base link to the ODOM and then put the height of the base link, the Z, we may be able to fix that issue.
Yeah, I'm not sure what the Stage ROS is doing. What?
I think several versions back they declared that they would introduce base footprint, and so I think they released a rep that said they will do that. And basically, as Sam was pointing out, base link is the center of your vehicle, and then base footprint is that projected down onto the ground. And I think if you do a search for base footprint, they'll somewhere, I think it was Tully Foot came out and said, we are going to start doing that. Just add that extra step in there. So I think that is on the newer stuff. I think that's official now that everyone uses that.
Okay.
Goes ODOM base link, ODOM base footprint, and then base footprint base link.
Guys, I think I have a problem with the Zoom, so I have to log back in.
So there are some pull requests to fix that. Kind of the one issue that we have is that Stage is publishing both the ODOM message and the base footprint. So we can't add the height. Anytime we try to, in the Z-axis, move the base link up, it gets overwritten.
Okay.
So maybe the version of Stage that we're using is older, and it uses the older convention.
Yeah.
What's new in your world, Tommy?
Yeah. We are just working along using ROS. We had a project where we want to simulate a tractor, so you're also pointing to this this project. I haven't downloaded it yet, but I just wanted to find a good tractor simulation also to add to our project. So yeah.
It's fun. We went with Stage instead of Gazebo. It's a little lighter weight. The Gazebo can do a lot and provide some excellent simulation.
Okay. A Stage ROS, is that a simulator? I haven't seen that before.
Yeah, it's a 2 or 2.5D simulator.
Okay. Yeah. I want to check that out. Also, this with a base footprint. I'm just Googling some of the.
So I just posted a link in the chat there. Somebody's talking about base footprint, where they're talking about adding that into that. It's Rep 105 that where they added it.
Yeah.
So if you look at the chat window there, I posted a link.
Okay.
Sorry, guys, I'm trying to get my video working. It seems like the Zoom's all finicky. Matt, I think in the meantime, if someone else have any comments or something, let me fix the video and I'll get back.
So this tracked lawnmower project, are you all working on that together, or how's that project?
Al roped us into building some robot lawn tractors, and so that's been a pretty nice sized platform. It's big enough that it's kind of a vehicle, a good learning platform.
Yeah.
Yeah, ask Matt to roll up his sleeve. You'll see the bruise on his arm where he was twisted up behind his back.
But yeah, Al's got a lawnmower. Al got me a lawnmower. Colin has a lawnmower, and Jeff is actually making his own small platform, and his is electric. But
Okay. Yeah.
he's using the latest technology, the electricity.
Yeah. Yeah.
But it's been fun. It's a nice vehicle to take out and drive around.
Yeah. 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 So you want to build up with the same motors and so on, build similar. So you each have your own hobby lawnmower tractor that's driving autonomous.
Yeah.
Yeah. Yeah. Cool.
I think it's a great learning platform. All the same technology. Obviously, the sensors and the types of motors and actuators will be different when you move to a full-size tractor, but all of the principles in the software are the same.
Yeah. Yeah.
We have to get some of Jeff's SIL 3 proportional hydraulic valves when we go to the tractor.
Yeah. You can get some of our motors.
Yes.
Yeah. Yeah, we have this motor you can buy and put on the steering wheel. So, I don't know if we have this Wheelman product.
It's not too late to change. Do you have mounting brackets?
Yeah, not for a lawnmower, I think. But it's not too hard to do, I guess. But right now, probably more how to get the interface on to ROS. But we have this. I'm just trying to find out.
Okay, guys, I don't have a video, but I think I can screen share. So let's continue if you want to.
Okay.
Okay, so let me share my screen again. All right, before we move on, I just wanted to show you one other cool command. I'm probably not sure that if you guys have used it or not, but I find it really useful. I'll share my screen. So obviously we would use the ROS topic. Everyone knows that command, and then you just list it. But if you add the V, what it does is basically it just gives you the published topics separately. It will also tell you the message type and the publisher, and also it will say subscribe topics. Will also give you the topic. It will also give you the message type and then how many subscribers that you have. So instead of just having a list, this would be useful just to get through it and just to see that what's actually just being published. I find it useful. I just use it sometimes, if I have to take a look at it, because many times I get confused, obviously, with a lot of message types and stuff. So this is kind of an easy way, just to take a look at it, that if there are any, the topics or, or you just wanted to see published topics, you just want to see the message type and stuff, along with the other command, that you just type it, and then it will just show all the info, and then you can just say -R to actually get also some of the information that how it's just being used. Well, that's just being running. You can also use the tf echo command, and that would, with the tf, the package, Now, it was still you still use the TF2 query. This TF's the old package, but you still had some good transformations that you use from the TF, and also some of the command line that I still use TF. But in most cases, when you program, you just want to use the TF2 library, which is like TF2 implementations, basically platform software independent. But for ROS, they have TF2 underscore ROS package, so you can use that. In this case, if you wanted to see that, just echo. Let's see if I just wanted to see only one time, and then just wanted to see add on to your base link. Oops. Okay, let me see. Hang on. Guys, the TF echo, how can I use it? Let me use it directly, and then I can. Oh, here you go. Okay, so I got the syntax wrong, so I'm just going to stop that. So over here, as you can see that from Autumn to base links, what's just giving me right now, which is basically my translations, my rotation. So in my quaternion, it just basically gives me nothing, and then my RPY just gives me 0, 0, 0 at this point. That's from my Autumn to base link, which is pretty much like at the beginning, because it's in line with your base link. So you expect that, but I mean, unless you set it up, it's just not going to be as perfect as you're looking at right now, because you initialize your ODOM and then your base link in the beginning, before your robot starts moving, should be in line. But I mean, this is like crazy in line. Like this is like perfectly in line, which I'm not sure that if we expect that or not. But this is how you can actually say, okay, well, give me the transform, that you just wanted to see the data, in your, the autumn, the frame, and you just wanted to see the baseline, what's the transform from autumn to the baseline, basically. So you can query anything, what you see. And then that's the beauty of the TF, right? If you have it's properly defined, you should have all the transforms for you, and it will just tell it to you, and it will just constantly also publish those transforms from any of your, the sensor frame to the baseline, to the autumn, to the map frame. So that's one of the other thing. Now let's go back to the RVs and take a look at the visualization. Okay, I'll share my screen and we'll go to the RVs. Okay, so now this is my RVs. I have to restart, so I'll just have to add my map, this topic again. And that we have already seen the map topics in the back end. That's just running. Once I do that, it will just put the map frame and bring it in from the map server. You can update that anytime. I haven't tried that many times. So just every time I have to just change the frame, I'll just start it again. And then, the launch, the whole, the file within the package. So and let me just put that in auto so that we can take a look at it. I'll just bring it down, center it. We'll just go a little bit further down over here so everyone can see it. The another topics that you wanted to add is just the autumn, the odometry. And that's, like we said, that's just being published at this point. For the simulation, it's just being published by the stage. Once we bring that in, we just wanted to bring in the path. So that we can see, and we'll just bring in the local path. Now, I think the local path over here is just being published by TEB Planner, right, Matt?
Yep.
And we just wanted to get in the the TEB local planner, and then that's what just local plan. We can actually see that, and then we just wanted to bring in. So, for example, what else we can bring in is just the pose. So we do that, just bring in the pose. Okay, so let's just bring in the pose over here, the topic. We're just going to say the current goal. And it will just change the color so that we have a distinction between the, because the odometer is also going to actually use the same color, if I'm not mistaken. Let me see. No, it's got the different color over here, the shade. And yep, it's got this color. So we're just going to pick maybe some other different color so that, you know, it has some distinction that it can make. And with that, you can see all the TFs. This is over here, and then it's just really nice to see, you know, the frames that when we move, and then, you know, see that if you can see the some of the position and the dimensions, just, you know, if it just keeps moving or not. So with that, we can actually publish the 2D nav goal directly over here, and once we put that, as you can see, that the pose is over here, and hopefully it's just not that finicky. If I wanted to zoom out, zoom in, it should, you can see that, you know, it's actually buffering a little bit of, you know, the pose. And this is the local planning that is just pose, and this is the pose. This is going to go and orient itself to that pose, and it's going to stop right here. And then this is the TB planner that's actually just moving it from point A to point B. As you can see, this we started from over here, and as you can see, your, you know, the base link, you know, it's got the transform, and now it's got the new position. You know, GPS is at the same position at this point, but there is a difference because of the mounting. Your camera frames is also moving because it's got the static transform, so you get the data into these frames over here, as you can see. This gives you a bit more visual. I think it's just really good to see that if it's just moving now, you can move this wall. It's basically act as a geofence. So if you have this black wall around here and you just want to say, okay, well, move my tractor to here, for example, my 2D navigation goal, just if I put it over here, it's just gonna say, oh, sorry, I can't move because I can't go there. But if I say my 2D nav, which is right here, hey, can you just get me over here? Then I will say, okay, I'll go there. So it's just basically, if you have the right PGM, the PNG or PGM file, whatever it is, your map file, basically, it should give you the, you know, the good fair amount of the geofencing, if you can have, you know, or even when you have just a thin or a little bit of thicker black border, I think that should suffice. In this case, you know, I have just used the whole block. Now over here, as you can see, for the one time, I mean, it just stopped right here, and it didn't actually complete the goal. But as you can see, I'll share the other screen where you can see that. What it says when it stopped. Hang on. So let me see the new share, and I'll just share this. And the share screen. So basically, as you can see over here, where it says my position onto the map that I provided for the first time, and then that's my 2D navigation goal. And that's my position, and that's my orientation that was given, basically. And then when it says it reached there, it says goal reached. The second one is just basically when I put the navigation, the point on the RVs, it would say failed to get a plan just because it just can't move there. And then for the third time, you know, this is the third position where we had the navigation goal that just trying to go there, but it didn't reach. So basically, it mostly works. As you know, the simulation sometimes just you have to restart it in order just to see it. So that's all we're at right now. So if you guys have any questions.
Are you
Sorry, Colin.
Are you happy with the movie? It looks like it's complex.
Colin, your audio was messed up. I don't think.
Sorry, Colin. Can you ask me again?
There's some feedback, but you can hear you now, Colin.
Yeah, my audio is reverberating. I don't know what's happening. Can you hear me?
Yes.
Yeah, I was saying to Sam, if I see if what I saw is what's happening, is he happy? It seems to be bubbling, particularly when turning, it's creating a thicker line than a smooth straight line. Are those areas you are working on? Or
Correct. Yeah. So right now that's just point A to point B. So and then we're not actually providing any. We're providing just 2 points, and the local planner, which was actually it's coming from a package, TB package, that's actually moving, that from point A to point B. I think going forward, and also that's our wish that if we have to actually provide the waypoints, so that it can move along those waypoints, and also it can actually move into the zigzag, the pattern if you wanted to heal your farm or wanted to do anything with it. But we're not there yet.
The reason that path looked wider when he was turning, it's actually putting little arrows on the screen. It's not just dots behind it. Those are, if he zooms in on, you can see those little arrows pointing the direction he's going. So as he's turning, the arrows are pointing sideways like this. So it looks like it's wider instead of just being individual points as it moves along.
oh, okay, all right. Thank you very much.
Thank you, Sam. Excellent work. Really interesting demo. Making
Right.
progress.
Yep, some progress.
Looks like we're at the top of the hour here. Thanks for being here. Any other last comments? All right. You guys have a great week. Oh, next week is Christmas, so that's Tuesday. So we'll skip that one and then meet the following Tuesday. I hope you guys have a great vacation.
Yeah, you too.
Happy holidays, guys.
Bye-bye.